Hello everyone. Today we're going to learn about a new topic, and today's topic is prime and composite numbers. So what are prime numbers and what are composite numbers? Now the whole number system can be divided into these two types of numbers. So first let us know what are these numbers and how do we classify the numbers as prime numbers and composite numbers. So first of all, let us know what are prime numbers. Prime numbers are numbers which are having exactly two different factors. In the earlier classes you have learned about factors and multiples. So from that concept we can come to this concept of prime numbers, that prime numbers are such numbers which are having exactly, means only, you can say, two different factors. So which are those factors? Those factors are 1 and itself, the number itself. In such a case, the number is called a prime number. For example, let us see here 2. What are the factors of 2? It is 1 and 2 itself. Factors of 3, 1 and 3 itself. Factors of 5, 1 and 5 itself. So in all these cases, what we can see, one common thing is that these numbers, that means the prime numbers, are having only two factors, and those factors are what? 1 and the number itself. So whenever a number, any number which are having only two factors, that is 1 and itself, the number itself, then such a number can be said as a prime number. Clear? And what are composite numbers? Definitely this is just the opposite of the prime numbers. Those numbers which are having more than two different factors are called composite numbers. For example, you can see here 4. What are the factors of 4? 1, 2 and 4. So definitely here there are more than two factors. Here there are three factors, 1, 2 and 4. Similarly 6 also you can see 1, 2, 3 and 6. These are the factors of 6. Similarly 8 also 1, 2, 4 and 8. So in composite numbers, the number of factors will be more than 2. This is the first thing. And as well as we can say this is the only difference between prime numbers and composite numbers. Or even you can say one thing, that the numbers which are not prime are composite numbers. It's the same thing. Okay, so moving on now, some important points that we should remember is that the number 1 is neither a prime nor a composite. Yes, this thing you should remember. Now why this is not a prime? Now if you see carefully, the number 1 has how many factors? It has only one factor, that is 1 itself. So according to the definition of prime numbers, it doesn't fit, because according to the definition of prime numbers there should be exactly two different factors, but here there is only one factor, that is 1 itself. And regarding the composite numbers definition also doesn't fit with this, because it should have more than two different factors. So the number 1 is neither a prime nor a composite, because it has only one factor, that is 1 itself. Now next is the smallest prime number is 2, and it is the only even prime number. Yes, if you are asked which is the smallest prime number, that is 2. And one interesting fact is that this 2 is only the prime number which is even. The rest of all the prime numbers are odd. Clear? Now moving on to find all prime numbers between 1 and 100. Yes, how to find out now the prime numbers between 1 and 100? Now one thing is that we can check it by trial and error method. We can check for ourselves that yes, whether it is a prime or not, it fits in according to the definition of prime or composite number. We have to check it in that way. Or other than that, there is a method called the Sieve of, the method is called the Sieve of Erastosthenes. So there was a Greek mathematician about 230 BCE. It was a long time ago. There was a Greek mathematician named Erastosthenes, So he developed a method of finding out the prime numbers between 1 and 100, and he gave the name of this method as the Sieve of Erastosthenes. So let us see now what is this method. So what he did is, he have written down all the numbers from 1 to 100 in 10 rows like this. He have written it in this way. This is a row and this is a column. Okay, so what a horizontal way if you write, it is called writing in the rows, and if you write it in a vertical way, then it is called writing in columns. So he have written in rows, 10 rows. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 rows. He have written 10 numbers in each row, 1 to 10, then 11 to 20. In this way, till 100 he have written. Then after that, what he have done, in step 1, first of all, what he have done is cross out 1. We have crossed this 1. It's just like a game, you can say. It's very interesting. So first of all, I have to cross out 1. Then what we have to do is encircle 2 and cross out the remaining multiples of 2. You have to circle this 2. After crossing 1, you have to circle 2, and then in this line, how many we can say multiples of 2 are there, all you have to cross out. Say for example, 4 is a multiple of 2, cross. 6, cross. 8, cross. 9, we will come to that, but yes, still 8 and 10 is also cross. You have to circle 2 and you have to cross all this. Okay, next what you have to do is encircle 3 and cross out the remaining multiples of 3. You have to now encircle 3, and which are the multiples of 3? 6, you have already crossed it. Then 9, yes, you have to cross it. Done. Next what you have to do is encircle 5. You have encircled 5 and cross out the remaining multiples of 5. The multiples of 5, 10 already you have crossed. Then encircle 7 and remaining multiples of 7. So not only in this line you have to cross out in every row. Whatever multiples of 2 are there, whatever multiples of 3 are there, whatever multiples of 5 are there, whatever multiples of 7 are there, all you have to cross out after encircling this. And whichever numbers are left which doesn't fall in this category, that means which are not the multiples of 2, 3, 5 and 7, those numbers you have to encircle it. That doesn't fall in the multiple of this what you can say 2, 3, 5 and 7, then those numbers you have to encircle. You can see here the next step. Now encircle each of the remaining numbers. Whichever numbers are remaining which are not the multiples of 2, 3, 5 or 7, those numbers you have to encircle. So we'll find that there are how many? There are in total 25 such numbers between 1 and 100 which are encircled. If you count it carefully, 1, 2, 3, 4, if you count it, there will be 25 such numbers, and these are the 25 prime numbers between 1 and 100. Clear? So this is very easy technique. You have to cross out the multiples. First of all, I have to cross out 1, then we have to cross out the multiples of 2, 3, 5 and 7, and whatever numbers are left behind, which are remaining numbers, those are the prime numbers between 1 and 100. So this was the method of Sieve of Erastosthenes of finding out the numbers between 1 and 100. Now moving on to the next topic, twin primes and co-primes. So what are twin primes and co-primes? So twin primes are those prime numbers which differ by 2. Say we are given 2 prime numbers, and what is their difference? You have to see. If the difference is 2, then those are called twin primes. For example, you can see 3 and 5. What is the difference between 3 and 5? 2. 5 and 7, 2. 11 and 13, 2. 17 and 19, 2. 29 and 31, 2. So all these pairs of prime numbers whose difference is 2, means which if we subtract we get 2, then those are called twin primes. Clear? Then what are co-primes? Those numbers are called co-primes, or 2 numbers are called co-primes if they have only 1 as their common factor. Yes. Say we are given some pairs of numbers, or some not any numbers, you can say some pairs of some pairs of prime numbers. Then if their common factor is only 1, then we can say that they are co-primes. Say for example 3 and 4. Yes, the only common factor is 1. 4 and 9, only 1. Now one interesting fact, if you see these co-prime numbers and twin prime numbers, one interesting fact if you see, all the prime numbers, or you can say all these co-prime numbers are the twin primes? No, but the opposite is correct. So all these twin prime numbers, are they co-primes? Yes, these twin prime numbers are co-primes, because if you see carefully, 71 and 73, what is the common factor between them? Only 1. So we can say that from these two concepts, we can say that the twin prime numbers are co-prime numbers. But yes, the co-prime numbers are not the twin prime numbers. Clear? Now moving on to the last topic of the day, that is prime factorization. So what is prime factorization? Expressing a number as a product of prime numbers is called prime factorization of the given number. So if you are given any number, and if you find out all its factors, and those factors are prime factors or prime numbers, then such a type of factorization is called prime factorization. Now there are two methods of prime factorization of a given number. The first one is called the division method, and the second one is called the factor tree. So we will see first the division method. So this is the division method. What we need to do is, say for example you are given number 90 and you have to find out its prime, we are told to find out its prime factors. Then what we need to do is we have to just divide it. We'll divide it by 2. 2 is a prime number. 2 divided by 90 is 45. Then we'll divide 45 by 3, 15. Again 15 can be divided by 3, 5, and 5 can be divided by 5, 1. So all these factors, except this one, all these factors will be on this side, left hand side. 2, 3, 3, 5, all this can be written as 2 into 3 into 3 into 5. So all these numbers are what? These are prime numbers. So we can say that these factors are prime numbers. So this type of factorization is called prime factorization. There is one more method called the factor tree. Why it is name given factor tree? Because it looks like a tree, although it is a bit bent, but it looks like a tree with its branches. These are some of the branches you can see. So it's also the same thing. 180 you can write as 2 into 90. Then this 90 can be written as 2 into 45. 45 can be written as 3 into 5, 15. Then 15 can be written as 3 into 5. And 5 can be written 5 into 1. Then all these numbers which are on the left hand side are its factors. Clear? So basically these two methods are almost similar, just the way of representing them is a little bit different. And if you ask which method to be followed for finding out the prime factorization, any of the method as you wish, you can find out, because the factors would be the same. In this case also it will be the same, in this case also it will be the same. So there is nothing much of a difference for finding out which method is best. All the methods are okay. Whichever you prefer according to you, which you like to do, you can do. So that's it for today then. I hope you all have understood all the topics that are covered in today's class. You can again go back to your textbook. There are a lot of examples. You can try it out and have a much more better clarity in these topics. So that's it then for today. Thank you and have a nice day.